Inside a laboratory in China, a machine is opening its eyes. Its skin feels warm like a living body, its chest rises and falls gently, and its face keeps changing with every word spoken by the person in front of it. In just a few seconds, the boundary between humans and machines begins to blur. This is no longer a vision of the distant future. The race is happening right now. China's ambition is not limited to building robots that can walk or speak. It is also working toward a new labor force that can enter almost every part of human life. But for a machine to truly live and work among people, it must learn to understand the world in the way we do. In this video, join Mandarin Tech as we explore how the world's most populous nation is gradually erasing the line between humans and machines. Humanoid robots have existed for decades, but most of them have remained limited to short demonstrations. They may take a few steps, wave their hands, or answer prepared questions. But even a small change in the surrounding environment can leave the entire system confused. China is determined to break through this limitation. By the end of 2025, Chinese companies had introduced more than 300 humanoid robot products, showing that the race was quickly moving from laboratories into real production. Under its National Development Plan, China aims to mass-produce humanoid robots, build a complete supply chain, and become one of the world's leading countries in this field by 2027. The drive behind this ambition is not only technological competition. China is aging rapidly, with more than 323 million people aged 60 or above by the end of 2025, equal to around 23% of the population. As the workforce may shrink and the demand for elderly care continues to rise, robots are expected to become part of the solution. The goal is therefore no longer to build machines that can simply perform on stage. Robots must be stable enough to work in factories and warehouses, skillful enough to use human tools, and intelligent enough to assist in hospitals and homes while handling situations that were never programmed in advance. To understand why China's robotics industry is developing so quickly, look at Shenzhen, where a design can become a working prototype in just a few days. At the center of this advantage is Huaqiangbi. Across an area of about 1.45 square kilometers, 22 specialized electronics markets offer more than 1 million types of components, from sensors and circuit boards to motors and control systems. If a robot joint does not work accurately, engineers can find a supplier, order a newly made part, and test it again almost immediately instead of waiting months for imported components. One company in Shenzhen once found 100 important parts in just 3 days and completed a production-ready prototype within 1 week. For another sensor company, the time needed to purchase components was reduced from 3 months to only 1 or 2 weeks. This ecosystem continues to expand. By the end of 2024, Shenzhen had around 210 companies working in the field of embodied intelligence robots, forming a network that connects core components, control software, and complete robot manufacturing. But fast production is only half of the advantage. In July 2025, a robot store based on the 6S model opened in Longgang District. On its opening day, 26 companies signed cooperation agreements, while more than 200 businesses expressed interest in joining. Here, robots are not only displayed, they are also sold, rented, customized, and tested in simulated real-life situations, allowing manufacturers to check their stability, ability to interact, and level of safety before bringing them to the market. At first glance, building a machine with 2 legs, 2 arms, and dozens of moving joints is far more complicated than creating a specialized robot. However, the world around us is already designed for the human body. Stairs, doorways, desks, vehicles, and tools are all based on human height, reach, and movement. A robot with a similar structure can enter these spaces without requiring an entire factory to be redesigned. The same basic frame can also perform many different tasks. A robot can use flexible hands to sort components, switch to a gripper to lift goods, or attach a specialized tool to work on a production line. When different robot models use the same motors, sensors, batteries, transmission systems, and joints. These parts can be standardized and produced in large quantities. This makes the supply chain simpler and helps reduce costs. China already has a strong foundation for this ambition. In 2024, the country installed around 295,000 new industrial robots, accounting for 54% of all robot installations worldwide. For humanoid robots, orders in the first 10 months of 2025 involved around 5,700 units, while the total number installed during the year was expected to approach 10,000. To prevent companies from developing in completely different directions, China has also begun creating its first national standards for environmental perception, planning, motion control, and task execution. By 2027, the country aims to build a safe and reliable humanoid robot industry chain capable of moving these machines from laboratories into factories, warehouses, and everyday life. Humans do not communicate through words alone. We read each other's eyes, notice a frown, and sometimes a simple nod is enough to understand what someone means. For this reason, a robot's face must become a precise system of signals, where the eyes, lips, and eyebrows move naturally together with speech. This development is happening step by step. One Chinese research team used only 9 small motors in a robot's face, but coordinated them into 17 movement units to create smoother expressions. Meanwhile, a headform developed a face with 30 moving muscle groups, capable of producing 12 micro-expressions while keeping the skin at around 36.5 degrees Celsius. Different companies are also following different paths. Some focus on eye contact and facial expressions, while others try to copy human skin, body warmth, and even breathing. The goal is not only to make robots look human, but to make every interaction feel so natural that the line between a living body and a machine slowly begins to disappear. One of China's early humanoid robots appeared in 2016 when the University of Science and Technology of China introduced Jia. With long black hair, a balanced face, and traditional clothing, Jia was quickly called the robot goddess. She could recognize speech, answer simple questions, move her lips while speaking, and make small facial expressions. In one famous moment, Jia asked a photographer to step back because the close camera angle could make her face look fat. The programmed comment went viral because it made the robot seem aware of how she looked. However, Jia's real abilities were still limited. Most conversations depended on prepared data and scripts. Her responses were sometimes slow, while her movements and facial expressions remained stiff. Even so, Jia was an important early step. She showed that robots did not need cold metal faces. Human-like appearance could make machines feel more friendly and become almost as important as the technology inside them. While Jia was mainly a research project, X Robots has brought highly realistic humanoid robots closer to industrial production. At the company's factory in Dalian, silicone faces lie beside robotic arms, feet, and unfinished mechanical frames. Technicians shape the skin, implant the hair, install the eyes, and adjust every small movement before attaching the head to the robot's body. X Robots does not only want its robots to show emotions, the company is also developing a multimodal artificial intelligence system that allows the machines to combine visual, audio, and language information to understand the situation around them. Instead of using the same smile in every situation, the goal is to help the robot choose an expression that matches the conversation. Each completed X Robots model takes about 2 weeks to 1 month to build. Prices announced in 2024 ranged from 1.5 million to 2 million yuan, equal to more than $200,000 at that time. But the company's long-term goal is much greater. It imagines these human-like faces being used in education, healthcare, and psychological support, where robots may need to communicate for long periods with children, elderly people, or patients. Yet a single mistimed movement, an unblinking stare, or a smile appearing at the wrong moment can instantly turn a feeling of closeness into discomfort. Meanwhile, Robotics is taking a different path, making robots smaller and lowering the price to a level that ordinary consumers can afford. The company's Boomi model is not the size of an adult and does not try to copy realistic human skin. Instead, it is designed as a small robotic companion for education, entertainment, and programming. Its starting price was announced at 9,998 yuan, far below high-end humanoid robots that can cost hundreds of thousands of dollars. This is a deliberate choice. Perfectly recreating an adult human requires a large frame, many motors, soft materials, cooling systems, and powerful batteries. Noatix removes many of these requirements and focuses instead on movement, interaction, and allowing users to develop new functions. A smaller robot is also safer around children. Its lighter weight reduces the risk of injury if it loses balance, while its lower height makes it easier to transport and use in classrooms. By the end of 2025, Noatix said Boomi had received 1,000 orders. In early 2026, the robot continued to appear at international events and major Chinese television programs. This suggests that humanoid robots are gradually moving from individual prototypes toward products that can be manufactured through a stable production process. A headform, however, is focusing its resources on the part people observe most closely, the face. Under the artificial skin of a headform's robots is a drive system with many degrees of freedom. Small, brushless motors control the eyelids, pupils, eyebrows, lips, cheeks, and neck. Cameras built into the eyes allow the robot to recognize the person standing in front of it, maintain eye contact, and coordinate movements between the head and the eyes. As a result, the robot does not simply turn its head toward a sound. It can move its eyes first and then turn its neck, similar to the way humans react when something suddenly catches their attention. Very short delays are also added to the movements, so the face does not respond with unnatural speed. A headform says its goal is to develop robotic heads that can express emotions, understand their surroundings, and create more natural interactions between humans and artificial intelligence. This approach fills an important gap in today's AI. A language model can produce very natural answers, but when it remains behind a screen, it still lacks a physical presence. A headform wants to give that intelligence a pair of eyes, a face, and the ability to respond through physical movement. For this reason, a headform's challenge is not simply to increase the number of motors. The real difficulty is controlling them according to the natural rhythm of human behavior. In early 2026, the gap between robots and humans became even smaller when Shanghai-based company DroidUp introduced Moya. Moya stands 1.65 meters tall and weighs 32 kilograms. But what makes this robot different is not only its size. Beneath its soft skin is a structure designed to copy human muscles, body fat, and the chest, making the body feel less like a metal frame covered with silicone. A temperature control system keeps the surface of the skin between 32 and 36 degrees Celsius. When users touch Moya's arm, they do not feel a cold surface like plastic or steel, but a warm layer of skin that feels closer to a living body. Cameras inside the robot's eyes allow it to recognize faces and maintain eye contact. During conversations, Moya can blink, nod, smile, and produce small facial expressions. Its appearance is designed in a modular form, allowing the face and outer look to be changed without rebuilding the entire mechanical frame inside. Moya is expected to be used in healthcare, education, and service environments rather than becoming a mass-market product immediately. At the time of its launch, its price was reported to be around 1.2 million yuan, equal to about $173,000. However, Moya's greatest value does not lie in how many units it can sell during its first year. Its real importance is that engineers are no longer studying only how robots look. They are beginning to study the feeling a machine creates when it shares the same room with a human. Robots can remember huge amounts of data, recognize thousands of objects, and calculate faster than humans. However, in the real world, something as small as a cup placed in the wrong position, a torn shopping bag, or a child suddenly running past can confuse them. Physical intelligence is not only about knowledge. A robot must observe its surroundings, understand commands, make plans, keep its balance, and control the force of its hands and fingers. A small mistake in measuring distance or gripping an object too tightly can cause the task to fail, damage property, or even hurt someone. This is why artificial intelligence on computers is developing faster than robots in real life. A wrong answer can be created again within seconds, but a wrong physical movement can have real consequences. The biggest challenge is data. Robots need more than text and images. They must also learn about force, impact, slippery surfaces, balance, and human reactions. This may become an advantage for China. When robots are widely used in factories and stores, every action can produce new training data. A skill learned by one robot can also be improved and shared with many others. However, repeating a task does not mean that a robot truly understands the world. The main question is not only when robots will become better than humans, but how safe and reliable they must be before we allow them to do jobs that directly affect our lives. From stiff robotic faces to warm skin and subtle expressions, Chinese robots are moving closer to humans in both their outward appearance and the intelligence controlling them from within. The robot revolution will not begin on the day machines become perfect. It will begin when robots become stable and useful enough for people to accept their remaining flaws. What do you think? Will humanoid robots become partners that free humans from dangerous and exhausting work, or will they gradually replace the very people who created them? Share your thoughts in the comments below, and do not forget to like the video and subscribe to Mandarin Tech as we continue exploring the technologies that are quietly rewriting the future of our world.